All right. Hi, everyone. Today I'm gone at a conference, and so I'll be back on Friday. Today we're going to talk a little bit more about standard form. I'm going to teach some stuff about how to work with standard form and how to find features given standard form. Mostly the vertex is really the big thing, and then the scale factor. And then after that, you're going to do some practice. It should be a pretty standard day. Let's do it. So this is sort of the same stuff as we started with yesterday, and so I just want to review that we can get some information based off of the graph and the equation. So here goes. We know that the vertex is always at the point HK when we're in vertex form, HK. And we know that the vertical scale factor is A. And we know that if A is positive, it opens up. If A is negative, we have it opens down. If A is greater than, I guess if the absolute value of A is greater than 1, we have a stretch. And then if we have A between 0 and 1, then we have a compression. Okay, this A is the same. B helps us figure out the vertex. Well, we talked about that a little bit yesterday. We found that the vertex is that the point vertex is at negative B over 2a, and then whatever f of negative b over 2a is. So that means that we're putting in negative b over 2a back in for x here and here. F of negative b over 2a. Oops. F of negative b over 2a. Okay. And then we still have the same rule about the stretch and compression. The other thing that we know is that the y-intercept is at the point 0c. Okay, 0c. All right, great. So now let's do some examples. We have a graph here where we have, and we're supposed to write it in vertex form. So we're supposed to start with f of x equals a and then x minus h squared plus k. We can find the vertex by looking at the graph, and we see that that's -1, -7. And so that's the vertex. We're going to use another point to find a, but I'm going to explain that in a second. So first I'm going to write out what I know so far. So I know f of x equals, I don't know a yet. That's going to be what I'm going to have to solve for. X plus 1. I'm writing plus 1 because h is negative, and I have a minus right here. Squared plus, and then -7. So I'm just going to write -7. Okay. Now I have that whole thing, but then what I need to do is I need to use another point to solve for a. And the way that I'm going to do that is I'm going to choose some other point that crosses a lattice point on the graph. So this is the point 2, -4. And I'm going to put that in for x and this in for y, or the output. So I'm going to write -4 equals a times, okay, wait. I have 2 plus 1 is 3. 3 squared is 9. So I have times 9. And then -7. Okay, so let's solve for a then. So I'm going to add 7, and I get 3 equals 9a. So then divide by 9, and I get a equals 1/3. Look at that. Okay, so now I know that actually this a is 1/3. So my final answer for vertex form is this: f of x equals 1/3 x minus h, but plus 1, squared, and then -7. Okay, and this actually makes sense too, because I can see that the graph opens up, and I can see that the graph is shorter than a normal parabola. Okay, the other part of this problem was to ask us to rewrite it in standard form. And so now we're trying to get into y equals x squared plus bx plus c. And the way that we do that, oops, there's a typo here. This should be a 1. The way we do that is we multiply out the x plus 1 first. We're going to use box method to do that. X plus 1 times x plus 1. We get x squared. We get x. We get x. And then we get 1. So together, that part right here becomes x squared plus 2x. And I see that there's 2 x's here because I have 1 here and 1 here. And then plus 1. That whole thing is multiplied by the 1/3, and then we have the minus 7 at the end. So we have to distribute first, then we can combine like terms. So we'll get 1/3 x squared plus 2/3 x plus 1/3, and then minus 7. This minus 7 is the same as 21 over 3. So I'm going to subtract 21 over 3. So I'm going to write 1/3 x squared plus 2/3 x, and then minus 20 thirds. This is f of x in standard form. So on the practice, you're going to go through this whole process where you take a look at the graph, and then you write it in vertex form. Then you multiply out your vertex form using the box method, and then you distribute and combine like terms to get to standard form. This is standard form. And this is vertex form. So these two graphs are the same. These two equations are the same for the same f of x. It's just it's two different forms. Okay, this is just a reminder that when we do standard form, to get the vertex, we take negative b over 2a, which is this number and this number. We use those numbers. And then what we do is we take that value and we put it back in for x. And that's what this whole thing right here says. So I'm going to do an example where I do that, and I'm going to show how that happens. Okay, here we go. So the vertex is negative b over 2a. So I'm going to do negative 6 over 2 times negative 1/4. Okay. So negative 1/4 times 2 is negative 1/2. Negative 6 divided by negative 1/2 is 12. Okay, so that's the x value. To get the y value, like I said on the last slide, is I'm going to take this x value that I know, and I'm going to put it in for x in both places. And so my x value is 12. My y value is what I get out when I put 12 in. So 12 squared is 144. 144 times negative 1/4 is negative 36. So now I get negative 36, and then plus 12 times 6 is 72, and then minus 1 is 7. Okay, so my answer here is negative 36 plus 72 plus negative 1, which is 35. So my vertex is 12, 35. My graph is not super helpful, but I'm going to go by 2s. And then my y-axis, I think I'm going to go by 5s. The reason that I'm doing that is because I know that this is going to open downwards because of the negative scale factor. And it's just going to make it possible to fit this graph on the thing that I provided. It's going to be a little messy, but that's all right. Okay, so the line of symmetry goes right through the vertex. So it's x equals 12. And that looks like just a vertical line that goes through 12 like this. Okay, the scale factor is negative 1/4, and that's a compression because it's 1/4 is less than 1, but it's greater than 0. So that means that this graph is going to be kind of shrunk compared to what we're used to, but also I changed the axes on my graph, so it's going to be a little bit tricky. The y-intercept is 0c. And so I know that it's going to cross right here. I could also mirror that point over here, right? Because of the line of symmetry. So that's about as best as I can do with that. The x-intercepts, we don't have a lot of tools to deal with. Long term, the thing that we will do to get x-intercepts is we'll put 0 in for f of x, and we're going to solve that equation. We just don't have a way to do that right now. And so I'm still okay with just sort of leaving that as an approximation. This graph will look something like this, and it should be really smooth. Here I am not drawing it very smoothly, like that, okay? They should be curved, and mine doesn't really look very curved. It should be nice and curved and really nice and smooth. I did the best I could. I am okay with you doing the best you can. I just want it to look like a U-shaped graph and not like a V. Okay. We're just going to say not yet on that. Okay, last example for the day. And in this example, we're going to do sort of the same thing. We're going to find the vertex. We're going to find the sketch of the graph. So let's see. The vertex is negative 6 over 2 times 1/2. Okay, 2 times 1/2 is 1. Wow. Okay, negative 6 divided by 1 is positive 6. So I get 6 and then whatever f of 6 is. So I'm going to put 6 in here and here. So 6 squared is 36, times 1/2 is 18, so this part is 18. 6 times negative 6 is negative 36. So I have 18 minus 36 and then plus 16. 18 minus 36 is negative 18, plus 16 is negative 2. So the vertex is at 6, negative 2, right there. I also know now that I can rewrite the function as y equals, a is 1/2, so I'm going to copy the 1/2, and then I'm just going to write x minus h, which is 6, squared, plus y minus k, or minus plus k, but k I know is negative 2, so I'm going to write minus 2 like that. So this is vertex form for the same parabola. And you can check this because you can multiply this out, distribute, and then combine like terms. Okay, the graph, if I go over 1, I will go up 1/2 from the vertex, but that's the only time I can use that rule. If I need to figure out other places on the graph, I think it would be wise for us to kind of put some values in. So what if I put in 8, or what if I put in 4, or what if I put in 10? Use some strategies, use a way to do this problem that will help you get an answer. So I'm going to put in 8 and see what I get out. 8 squared is 64, times 1/2 is 32, minus 48, and then plus 16. And so I get 0. And so that means I'm going to mirror that dot out there. And now I have a good number of points. The other place that I have that I know because of what I know about standard form is that I have my y-intercept is 0, c, and c is 16. So I can put a dot another 16 above there, right? I think it'll be right about here. And then I'm going to mirror that over here too. I just have to move my thing over here. Something like that. So now this graph should look like this. It's just going to smoothly connect all of these points. That's about as good as I can make it. Okay, so I'll just zoom out a little bit so you can see this whole thing. Okay, summary slide. I think everyone needs to have all of this information in your notes because you have to have some formulas that will allow you to get answers. So if you have standard form, This gives us all of the things that we can get out of standard form. We know that we can do negative b over 2a and then put it back in to get the y value. That'll tell us the vertex. We know our vertical scale factor is a. We know our y-intercept is 0c. From vertex form, we know even more stuff because we can figure out the vertex, we can figure out the y-intercept, we can figure out the vertical scale factor, and from there, we can graph. Okay, this is a lot of stuff to hear me talk about. You have a practice sheet that the substitute has for you. Please complete it. Everyone needs to turn it in at the beginning of class on Friday. I think you'll have time in class to finish it, but if you don't, you need to take it home and bring it to me on Friday. Have a great day. I will see you Friday.